Erin, good to see you.
You too.
Uh, I was thinking about talking about how do we, possibly the most common question we get in the CellProfiler forum, which is how do I figure out how many of my objects are percent positive for a particular marker?
Ooh, that's a nice
Yeah.
that's a nice question.
Yeah. People ask us that all the time because usually people spend lots of time making these lovely like protein fusions or optimizing antibodies and they want to figure out how many cells are positive for marker X. And there's lots of ways to do it, but I have one particular that's a favorite. um, when the marker is big, and one particular that's a favorite when the objects are small. And so I thought I might show that.
Yes, please do. I want to learn your tips and tricks.
All right. Um, so this is just some data that I've grabbed from the IDR, as we often do, where we have a nuclear marker, which is here in red, a cell marker, which is here in blue. I just left FIJI on the default colors. And as usual, I'm opening up new images in FIJI because I think it's easy to look at new images in FIJI. But we also have two different fluorescent proteins that are overexpressed, one that is a cell marker and one that is a nuclear marker. And we have some cells that have one, and some cells that have the other, and some cells that have both. And so I'm sure for the biologists in question, it is super important to know probably mostly about what are the cells that have both. So we'll make both single positives and then the double positive. Um, uh, we'll also, and then I'll quickly show what happens when you want to do this with speckles. Um, so I have preloaded a cell profiler pipeline that I spent literally just about 5 minutes tuning, where we can make our nuclei and our cells from our cell channel. Um, these are really gorgeous images, and so this was easy peasy. As always, you can find the pipelines for this episode on our website. So I'm going to start by showing you the thing that people often do, but that is actually a less good thing to do. So this is the less good thing. Don't do this. Um, so often what people will do is do something like measure object intensity followed by filter objects. And this will work. I'm going to show you something and it will work. But then I'm going to explain to you why maybe it doesn't work the best. So let's use this for our cell marker. So let's say we have I've called my channels DNA cells, cell FP for cell fluorescent protein, and nuclei FP for nuclei fluorescent protein. Very imaginative. So let's say I want to measure inside the cells the amount of cell FP. That would be probably a good way to figure out if the cell is positive or not. Um, I'm going to take advantage of the workspace viewer, which I got from this view workspace button, which is always delightful for figuring out um, how I can sort of put measurements on top of things. Um, and so if I have my cells, um, I can put my measurements of my cells right on top um, of my image, and I can get a sense of what's going on in terms of my cell. Let's go with the mean intensity. Um, so I bet one or two significant figures would probably have been enough, but um, let's zoom in and see what we see. It's a little bit hard to see with everything big. So it looks like in my cells that are negative, I have mean intensities that are really right around 0. Um, and in some of the other ones, I have like point oh 0.01 almost, maybe not quite everywhere. Okay, so that one thing that I can do is I can say I'm going to use the filter objects module, and I can sort of say I only want to keep cells that are above, let's say 0.007 intensity. And again, this will work. Um, uh, so I'm going to say I have cells. I want to limit their intensity and their mean intensity in the fluorescent protein image such that I don't care about the maximum mean intensity, but I want the minimum mean intensity to be 0.007. And I got that just from sort of looking around. Um, and so if I do that, we end up with about half of our cells, which sort of order of magnitude seems right to me. Um, and just for fun, because I want to sort of see what's going on here, I could make an overlay outlines module, and I probably will eventually. Um, but if this were a real project, but for now I can just use the workspace viewer. I can turn off the font thing, and I can say, show me in pink all of the cells that were marked as fluorescent protein positive, and all of the ones that are not are still marked in green, but because the pink gets drawn on top of the green, what we end up with is sort of a pink-green mask. And yeah, that seems to have worked fine.
Yeah, I can see,
Um,
a few cells that maybe if I were manually annotating, I would have thrown into a different bucket. But
yeah.
it seems like for a situation where you have really, really clear difference between, signal
Mhm.
or not,
Yeah.
this is not an unreasonable thing to do.
Mhm. Yeah. The reason I don't like this, is what if tomorrow you turn up your gain on your microscope just a very little bit? Maybe 0.006 isn't the right number anymore. And I
Mhm.
have to go through that process that I just did of like going through and looking at a bunch of cells and looking at the measurements, and it takes a while. It's not bad, but it takes a while. Um, so my actually preferred way of doing this, so now we're going to show you the one that I do like, is to start by actually thresholding the image, um, of the image that we're going to use to sort of call positive or negative. So here I'm going to do it for the nuclei. And the reason I like this is because CellProfiler's thresholding methods are pretty adaptable. As long as the sort of shape of the distribution doesn't change, as long as sort of, your stuff is sort of about the same percent bright and dim, you can adjust the gain on your microscope 2x tomorrow, and it doesn't really matter, because CellProfiler's thresholding modules just sort of deal with that. Um, ooh, here my nuclei are super dim, so I'm gonna do what I often do in this situation, which is change my default visualization settings, um, so that I can um, be able to sort of quickly tune lots of things and see if things look good. But that was apparently not the right number, so maybe I should just actually try to figure out what the right number is instead of guessing. Um, okay, what if I don't do log normalized and just do regular normalized? Okay, that is better. I can also make this image bigger too. But what we can sort of see right now in our very incorrectly thresholded image is there are actually a bunch of like dimmer things in addition to the brighter things. And that's what um, thresholding works really well at coping with. Um, so I'm just going to change this to normalized. Or no, I'm going to stay with log normalized and just sort of do it way higher. What can I say? I'm chaotic. So now we can see both our dim cells and our bright cells. These have a value of about 0.002. These have a value of like 0.01. So these are literally 5 times brighter, but I'm going to go ahead and assume that as the biologist, I care about and I want both. Hopefully a way that's going to help me get both pretty easily is by using the 3-class OTSU thresholding method in CellProfiler in this particular case, because what that says is, hey, CellProfiler, there's going to be 3 kinds of pixel intensity in this image. There's going to be background, there's going to be dim stuff, and there's going to be bright stuff. And you can decide what you want to do with that middle class. So here I want to keep the sort of dim stuff. So I can say that I want to keep the middle channel in the foreground. Gorgeous. But if I didn't, if I decided, no, actually, I only want the super bright cells, I could just set that to background.
Look at that.
I
Super.
love when, the theory actually works. Um, so if you have your thing thresholded, which as you can see is very adaptable, then we can use the mask objects module instead of the filter objects module in order to figure out our fluorescent protein positive nuclei. Um,
And again,
Um,
just to point out, in your threshold, like you didn't set any specific cutoffs, right? So it's
oh,
dependent, it is finding, it doesn't matter
mhm,
if your relative intensities from one day to another are different.
mhm,
That
okay,
the,
mhm,
yeah, that's a handy tip.
yeah. Um, and so what I can do with mask objects, so I've said that I want to mask my nuclei image. I want to do it with this thresholded image. And here's the magic button. The handling of objects should be set to remove depending on overlap. So here you can say, keep this object if it overlaps by X%. So here I'm going to just start with my default, which is 50%. And so any cells that are nuclei positive or that are 50% covered get kept, anything else gets thrown away. And just because these ones are relatively rare and I happen to have them open side by side, I can automatically see like this looks pretty good, though I could have gone into the workspace viewer to do that also. Um, awesome. Um, and
That's
mask objects is
magic, Beth. Like
yeah.
I mean, a really fun thing to point out in that there are so many different things that CellProfiler can do, and so many different settings you can tune, but that you know, sometimes it takes having an expert who is familiar with all these different options to show you, like, hey, this is actually quite an easy thing. Once you've been introduced to this, anybody can replicate this in their own workflow, but
Mhm,
may not, an average biologist just starting to think about the thinking around identifying objects in a quantitative and reproducible manner might
mhm.
not think to piece together these tools in this way.
Yeah. No, and the downside of CellProfiler having so many things it can do is it has so many things you can do, and sometimes it can be hard, to figure out what is the best way. Like, this is a way that will work. This is a totally reasonable way, but this is my favorite way. Um, I also like using mask objects then for figuring out our double positives. And so once we have single positives, very often what we want is our double positives. So I'm going to start with my FP positive cells. And and I'm going to say FP positive cells should be cells that have FP positive nuclei on them. And now I'm going to change this handling thing again. So if I change this to keep overlapping region, we can see what will happen. Which is it would only keep the parts of the cell that
Mm.
were actually overlapping, which is possibly what I want, but probably not if what I care about are cells.
Mhm.
Um, but I can just change it to keep. So now if there's a fluorescent protein positive nuclei on top of a fluorescent protein positive cell, it will just keep the whole cell. Ta-da!
Wow. Look at that.
And so now I have a thing that does only my fluorescent positive cells. And if I wanted the double positive nuclei, all I would have to do is sort of take this and reverse it, where I start with the fluorescent positive nuclei, and then I mask them with the fluorescent positive cells. Um, and then I could do whatever measurements and things that I wanted, um, and know are my measurements coming for. I could decide if I want to measure only the fluorescent positive cells and nuclei. I could decide I want to measure all of them, but I then just want to see, like, are they positive or not? All of these things would then be possible. I just need to know exactly what's the biology that I want to measure here. Um, so for all the questions that we get about this, it's really just a matter of knowing the right tricks, and then you're usually in really good shape.
That's awesome. I wouldn't even have necessarily thought or known to assemble these widgets,
Mhm.
aka modules, in this exact manner. This is lovely, Beth.
Thank you. If we've got time, I want to show you one more quick thing, which is this is great for when I can say, all right, my thing should be like 50% positive.
Mhm.
That's great when we have things like this that fill the whole nucleus or the whole cell. But if you remember back to our sparkly episode, that is not always the case. And sometimes we just have a few little sparkles. Um, so I want to quickly show what you would do in that case, because it's going to just add one module in addition to the module that we built in that episode. Um, So if I tell CellProfiler to open my Speckly project instead. Um, so here, oh no, it doesn't seem like I saved the final thing. Oh, bummer. Okay, um, I'm gonna quickly add my Speckly objects into this pipeline.
Do, 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 do. Maybe I'm not allowed to hum that, the copyrighted tune.
Probably.
Probably.
I think I had success. And we definitely want to use robust background here. And if you don't know why, go check out that episode. Um,
The Sparkles, aka Speckles episode.
yes. Um, so I'm going to use relate objects to now say, I want to know for each pseudo cell how many speckles slash sparkles of channel 3 that I have. Um, and so we now have in relate objects, we can see that our objects, our spots here are colored by the number of cells that they're on top of. So that mask object trick is great for when your marker covers a lot of your object. If
Mhm.
it doesn't, this is the better trick, is to do relate objects. And now we are actually going to use filter objects. And we're going to say, I want to sort of only keep things with a certain number.
Mm.
So, and so here I'm going to say that I have a thing called cells with lots of speckles. And I'm going to say I want only cells that have, I don't care about the maximum here, but I only want ones that have at least 10 speckles.
Mm.
And so hopefully that is also a thing that is going to be relatively sort of experiment to experiment, relatively consistent. So that's 2 of my 19 cells. So the more you can think about what's going to be consistent experiment to experiment, the more you can make a pipeline that you don't have to adjust every time you do an experiment.
That's a great principle to think about, certainly for this use case, but just building quantitative bioimage analysis pipelines in general,
Mhm.
a really good thing to keep forefront in your mind as you work on any new pipeline.
Yeah. I want folks to generally be lazier at building pipelines, and the way you make them lazy but still useful is by thinking about what's going to change each time and not building your pipelines around that.
Absolutely.
Well, thank you so much for letting me show you all my favorite tips and tricks.
I love it. I'm even learning new things. This is delightful. I hope this was useful for other folks as well. I'm sure it will be, given how often we are asked how to do this very thing.
All right. See you next time.
Sounds good. Bye.